differentiation of a raised to log cosec inverse x is 10. Outermost function is a raised to, so rest of the functions will be considered within the box. Differentiation of a raised to box will be a raised to box into d by dx of box. So within the box we have log cosec inverse x is 10. Now our first term will be as it is. We just have to focus on differentiation of log cosec inverse x base 10, and for that we should change base of log using property of log. According to property, we can say numerator will get log cosec inverse x upon log 10 base e. Now this log 10 is constant, we don't have to worry about it, it can take outside the differentiation, so it will be 1 upon log 10 will be as it is. Now we just have to focus on differentiation of log cosec inverse x. Here these two terms will be as it is, and to differentiate log cosec inverse x, log is your outer function and cosec inverse is your inner function. So let's consider box around the cosec inverse x. So differentiation of log box will be 1 upon box into d by dx of box. Within the box we have cosec inverse x, so we just have to multiply differentiation of cosec inverse x, which is minus 1 upon mod x under root of x square minus 1. So tada, you can consider this as your final answer. Here we have to differentiate tan inverse under root of 1 plus cos x by 2 upon 1 minus cos x by 2. So first of all, let's simplify this term and then differentiate. Let's use the formula of tan a by 2. Under root of 1 plus cos x by 2 and 1 minus cos x by 2 can be converted into 1 upon tan half angle, or we can say x by 4, and this d by dx and tan inverse will be as it is. Now 1 upon tan is simply your cot x by 4. So now here we have tan inverse of cot x by 4. As we know, cot and tan are complementary function of each other, so we can say cot x by 4 can be rewrite as tan pi by 2 minus x by 4. So now we get tan inverse tan pi by 2 minus x by 4. Tan inverse and tan are inverse function of each other, so we can say it can be simplified as pi by 2 minus x by 4. Now differentiation of pi by 2, which is purely constant term, will be 0, minus differentiation of x by 4 will be minus 1 by 4. So tada, minus 1 by 4 is your final answer. Here we have to differentiate tan inverse sec x plus tan x. So first of all, let's simplify our bracket, which is sec x plus tan x, which can be rewrite as 1 upon cos x plus sin x upon cos x. So we have same denominator as a cos x, so simply add the numerator. So here we'll get 1 plus sin x. For further simplification, we can say sin x can be rewrite as cos pi by 2 minus x, and this cos x can be rewrite as sin pi by 2 minus x. Using the formula of cos 2a, 1 plus cos 2a is equal to 2 cos square a. So let's use the formula in numerator. So we will get 2 cos square half the angle, or we can say pi by 4 minus x by 2. And in denominator, we can apply the formula of sin 2a. So here we'll get 2 sin half the angle, which is pi by 4 minus x by 2, and cos half the angle, which is pi by 4 minus x by 2. So we can simplify these terms as 2 cancel out, 1 power of cos will cancel out, and we will get cot pi by 4 minus x by 2. Now, let's get back to the question, which is differentiation of tan inverse of our bracket. Now, we already simplify the bracket as cot pi by 4 minus x by 2. For further simplification, your d by dx and tan inverse will be as it is. We should convert this cot in terms of tan. And tan and cot are complementary factor of each other. So we can rewrite as tan pi by 2 minus pi by 4 minus x by 2. So tan inverse and tan are inverse function of each other. So we can simplify this as pi by 2 minus pi by 4, or we can say pi by 4 plus x by 2. So differentiation of pi by 4 will be 0 and differentiation of x by 2 will be 1 by 2. So your final answer is B, 1 by 2. Ta-da! Let's see this question. If fx is equal to sine inverse of 1 minus cos 2x upon 2 sin x, then we have to find mod f dash x. Let's get our fx. In numerator, we can apply 1 minus cos 2x can be rewrite as 2 sin square x upon this 2 sin x will be as it is, and your sine inverse function will also remain as it is. So simply 2 and 1 power of sine will be cancelled out, and we will get sine inverse of sine x, which can be rewrite as x. So your fx is simply x. So we can say your f dash x is differentiation of x, or we can say 1. So your mod fx is also 1, which is in option D. Ta-da! Here we have to differentiate sine inverse 3x minus 4x cube, and 3x minus 4x cube is similar as 3 sin a minus 4 sin cube a, right? So it is preferable that we should assume x is equal to sine theta, where theta is belongs to 0 to pi by 2. Let's substitute the value of x within the question. So your d by dx sine inverse will be as it is 3 instead of x. You have to put sine theta minus 4x cube, or we can say sine cube theta. And as we plan, 3 sine theta minus 4 sine cube theta will be rewrite as sine 3 theta. Your d by dx and sine inverse will be as it is. So here we get sine inverse of sine 3 theta, which is simply d by dx of 3 theta. But we should convert this theta in terms of x. Instead of this theta, we have to write down sine inverse x. So here we just have to differentiate sine inverse x, because 3 is constant, we don't have to worry about it, and differentiation of sine inverse x is 1 upon under root of 1 minus x square. So ta-da! Option A is your final answer. Here we have to differentiate tan inverse of 1 plus x upon 1 minus x. To simplify the bracket and get in terms of tan theta, we should assume x is equal to tan theta. So our bracket, which is 1 plus x upon 1 minus x, will become 1 plus tan theta upon 1 minus tan theta. Now, to simplify this, we can rewrite this one as a tan pi by 4 plus tan theta will be as it is, and our in denominator 1 minus this tan theta is already within the multiplication of 1, so we can say this is nothing but tan pi by 4 into tan theta. So here we get tan alpha plus tan beta upon 1 minus tan alpha tan beta form, tan alpha plus beta, or we can say pi by 4 plus theta. So your y, which is tan inverse 1 plus x upon 1 minus x, can be rewrite as tan inverse of tan pi by 4 plus theta. So here we get tan inverse tan pi by 4 plus theta. Tan inverse and tan are inverse function of each other, so they will be cancelled out, and this will become pi by 4 plus theta. Or we substitute the value of theta, we will get pi by 4 plus tan inverse of x is your y. But we need its differentiation, so your dy by dx is simply differentiation of pi by 4, which is purely constant term, will be 0, plus differentiation of tan inverse x will be 1 upon 1 plus x square. Ta-da! This is your answer. In this question, we have y is equal to sec inverse 1 upon 1 minus 2x square. To simplify our y, this 1 minus 2x square is quite similar with 1 minus 2 sine square a. So, it is preferable that we have to assume x is equal to sine theta, where theta is belongs to 0 to pi by 2. So, let's substitute the value of x, and you will get your y is equal to sec inverse of 1 upon 1 minus 2 sine square theta. For further simplification, your sec inverse will be as it is. This 1 minus 2 sine square theta will be converted into cos double the angle, or we can say 2 theta. And we all know that this 1 upon cos 2 theta can be rewrite as sec 2 theta. Sec inverse and sec can be removed because our theta is belongs to 0 to pi by 2. So we can say we get y is equal to 2 theta, or if we substitute the value of theta, we'll get 2 sine inverse x. But we need dy by dx. So we just have to differentiate sine inverse x. So here we'll get 2 differentiation of sine inverse x is 1 upon under root of 1 minus x square, which is your option B. Ta-da! In this question, we have to differentiate tan inverse of root x 3 minus x upon 1 minus 3x. So first of all, let's get our y, which is tan inverse 3x raised to 1 by 2 minus x raised to 3 by 2 upon 1 minus 3. This x can be rewritten as square of root x. So here we get the right hand side of tan 3 theta's formula, which is 3 tan a minus tan cube a upon 1 minus 3 tan square a. So it is preferable that we should assume x raised to 1 by 2, or we can say root x is equal to tan theta, where your theta is belongs to 0 to pi by 2. So your y, which is tan inverse of 3 root x, can be rewritten as 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta. Now, as we plan, our whole bracket is become tan 3 theta. So, we get tan inverse of tan 3 theta, and our theta is already within the 0 to pi by 2, which is in the range of tan. So, we can cancel tan inverse and tan, so we'll get 3 theta as your y, or we can say we will get 3 tan inverse of root x. But we need differentiation of y, so we don't have to worry about this 3, we just have to differentiate tan inverse of root x, which is combination of tan inverse and root x. Tan inverse is outer function, so let's consider box around the root x. So your 3 will be as it is. Differentiation of tan inverse box is 1 upon 1 plus box square into d by dx of box. Within the box we have root x. We just have to multiply differentiation of root x, which is 1 upon 2 root x. So finally we will get dy by dx is equal to 3 upon 2 root x within the bracket 1 plus x. Ta-da! This is your final answer. In this question, we have y is equal to sine inverse of 2x upon 1 plus x square plus sec inverse of 1 plus x square upon 1 minus x square. Now, for simplification, first term will be as it is, and let's convert this sec inverse in terms of cos inverse. Here we'll get cos inverse reciprocal of bracket, and we can say 1 minus x square upon 1 plus x square. Now, as we know, sine inverse 2x upon 1 plus x square is simply 2 tan inverse x plus cos inverse 1 minus x square upon 1 plus x square is also 2 tan inverse x. So, we'll get y is equal to 4 tan inverse x. To get dy by dx, 4 will be constant. We just have to differentiate tan inverse x, which is 1 upon 1 plus x square. So, option C is your final answer. Ta-da! Here we have to differentiate tan inverse a plus x upon 1 minus ax, which can further simplify as tan inverse a plus tan inverse x. So, differentiation of tan inverse a is simply 0 because a is constant, so tan inverse a is also constant, and differentiation of tan inverse x is simply 1 upon 1 plus x square. So, ta-da! This is your final answer. Here we have y is equal to tan inverse a cos x minus b sin x upon b cos x plus a sin x. For simplification, let's divide our numerator and denominator by b cos x. तो सभी के नीचे b cos x लिखना पड़ेगा. So we can cancel out cos x, bb, cos x and bb. Your tan inverse will be as it is, and your bracket will become a by b minus sin x by cos x can be divided as tan x upon, here we'll get 1 plus a by b into tan x, which is actually tan inverse alpha minus beta upon 1 plus alpha beta. We can say here we'll get tan inverse of a by b minus tan inverse of tan x. So finally we can say your y is equal to tan inverse of a by b minus tan inverse tan x can be rewritten as x, but we need dy by dx. Differentiation of tan inverse a by b will be 0 because it's a purely constant term, and differentiation of x will be 1. So minus 1, which is within the option B, is the final answer. Ta-da! In this question, we have y square is equal to 100 tan inverse x plus 45 sec inverse x plus 100 cot inverse x plus 45 cos sec inverse x. We have to find dy by dx. Now, before we go for differentiation, let's simplify. Collect the terms of 100. So we'll get 100 tan inverse x plus cot inverse x. And from the rest of the two terms, we can take 45 common. So we'll get sec inverse x plus cosec inverse x. Now, we all know that tan inverse x and cot inverse x are complementary function of each other. So its summation will be pi by 2. Similarly, sec inverse x plus cosec inverse x is also pi by 2. So we get y square is equal to 50 pi plus 45 pi by 2. So if we differentiate with respect to x on both sides, we will get 2y dy by dx on the left side and 0 plus 0 on the right side because both terms are purely constant term. Or we can say your dy by dx is simply 0, which is given in option D. Ta-da! Here we have y is equal to sine inverse under root of 1 minus x square, and we have to find dy by dx. Yes. So here we have our y, and we all know that sine inverse of under root of 1 minus x square is equal to cos inverse x. So let's rewrite as cos inverse x. Now, to get dy by dx, let's differentiate with respect to x on both sides. Differentiation of cos inverse x is simply minus 1 upon under root of 1 minus x square, which is your option C. Ta-da! Here we have y is equal to sine inverse under root of 1 minus x plus cos inverse under root of x, and we have to find dy by dx. For simplification, we can rewrite this x as a square of the root x. So, using conversion property, we can rewrite sine inverse under root of 1 minus root x the whole square as cos inverse root x, and this cos inverse root x will be as it is. So finally we get y is equal to 2 times cos inverse root x. Now to get dy by dx, we have to differentiate with respect to x. We don't have to worry about this too. And to differentiate cos inverse root x, we have to consider box around the root x. So differentiation of cos inverse box is simply minus 1 upon under root of 1 minus box square into d by dx of box. Within the box we have root x. So simply we just have to multiply differentiation of root x, which is 1 upon 2 root x. So for simplification, we can cancel out this 2 and we will get minus 1 upon under root of 1 minus x and x, which is given in option B. Ta-da! In this question, we have y is equal to log sin x base cos x into log cos x base nx plus sine inverse of 2x upon 1 plus x square. Then we have to find dy by dx at x is equal to pi by 2. So here we have two different terms. First one is related with the log and another one is related with the inverse trigo. So let's simplify separately one by one. So let's assume our first term as a u. Here we have our u. We have two different terms of log in multiplication. So let's apply the property of change of base. So log sin x base cos x can be rewritten as log sin x base e upon log cos x base e into. Similarly, we can simplify the second term as log cos x base e upon log nx base e. So as you can see, log cos x can be cancelled out, and our u will be equal to log sin x upon log nx. Let's differentiate both the sides with respect to x. So on left side, simply get du by dx, and on right hand side, we have to apply division rule. And according to division rule, in first term, your log nx will be as it is. We have to differentiate log sin x. To differentiate log sin x, we have to consider box around the sin x. So differentiation of log box is simply 1 upon box into d by dx of box. Within the box we have sin x. So we just have to multiply differentiation of sin x, which is cos x, minus, in second term, your log sin x will be as it is. We just have to multiply differentiation of log nx. And to differentiate it, you have to consider the box around dnx. So differentiation of box is simply 1 upon nx into differentiation of your nx, or we can say it will be n upon log nx the whole square. Now, in further simplification, you can say your log nx is as it is. Cos x upon sin x is simply your cot x minus this log sin x will be as it is, and then we'll cancel out and we will get divided by x upon log nx the whole square. So finally we get our du by dx. Now we should move to the second term. Let's say it is your b, which is sine inverse 2x upon 1 plus x square, which can be rewritten as 2 times tan inverse x. So we are ready to differentiate with respect to x. So we simply get dv by dx is equal to 2 times differentiation of tan inverse x, which is 1 upon 1 plus x square. Now let's get back to our original question. Our y, which is equal to u plus v. If we differentiate with respect to y, we will get dy by dx is equal to du by dx plus dv by dx. And we know the value of du by dx. Just place it over here. Plus the value of dv by dx will be placed over here. So we get our dy by dx, but we need dy by dx at x is equal to pi by 2. So let's place x is equal to pi by 2 log nx, or we can say pi by 2 into cot x, or we can say cot pi by 2 minus log sine pi by 2 upon pi by 2 whole divided by log n pi by 2 the whole square, plus in second term we have to put 2 upon 1 plus pi by 2 the whole square. Now let's simplify. The value of cot pi by 2 is 0 minus sin pi by 2 is 1, and the value of log 1 is also 0 upon your bracket, plus from the second term we will get 2 upon 4 plus pi square into 4. So finally we get our dy by dx is equal to 0 plus 8 upon 4 plus pi square, which is given in option A. Ta-da! In this question, we have fx is equal to cos inverse of 1 minus log x the whole square upon 1 plus log x the whole square. And we have to find f dash t. Now, our bracket, which is 1 minus log x the whole square upon 1 plus log x the whole square, is quite similar with the right hand side of formula of cos 2a, which is 1 minus tan square a upon 1 plus tan square a, which suggests that we have to assume log x is equal to tan theta, where theta is belongs to 0 to pi by 2. So your fx will become cos inverse of 1 minus tan square theta upon 1 plus tan square theta. As we plan, cos inverse will be as it is, and this 1 minus t square upon 1 plus t square will become your cos double the angle, or we can say cos 2 theta. Now, our theta is belongs to 0 to pi by 2. So, we can eliminate cos inverse and cos, and your fx will simply 2 theta, or if we substitute the value of theta, we will get tan inverse of log x. But we need f dash e. So first of all, let's get f dash x by differentiating with respect to x. We don't have to worry about this too. Just differentiate tan inverse log x, where log x is the inner function. So we have to consider a box around it. So in first step, simply differentiate of tan inverse box, which is 1 upon 1 plus box square into differentiation of box. Within the box, we have log x. We just have to multiply differentiation of log x, which is 1 by x. So your f dash x can be simplified as 2 upon x into 1 plus log x square. Now to get f dash e, just place x is equal to e. So we'll get f dash e is equal to 2 upon, instead of x we have to put e, 1 plus log e this square. So we can simplify it as 1 plus, instead of log e we just have to put 1 square. So here we'll get 1 upon e as a final answer, which is given in B. Ta-da! Here we have to differentiate tan inverse under root of 1 plus x square plus under root of 1 minus x square upon under root of 1 plus x square minus under root of 1 minus x square. Here we have under root of 1 plus x square and 1 minus x square. So it is preferable that we should assume x square is equal to cos 2 theta. So we can say under root of 1 plus x square will become under root of 1 plus cos 2 theta, or we can say under root of cos theta. Similarly, your under root of 1 minus x square will become under root of 1 minus cos 2 theta, or we can say root 2 sine theta. So our d by dx of tan inverse will be as it is, and we can simplify our bracket as root 2 cos theta plus root 2 sine theta upon root 2 cos theta minus root 2 sine theta. Now, we should convert the bracket in terms of tan because we have tan inverse, and for that we have to divide numerator and denominator by root 2 cos theta. So we will get 1 plus tan theta upon 1 minus tan theta. Let's further simplify this. Instead of 1 we can place tan pi by 4 plus tan theta will be as it is upon this 1 will be as it is, and tan theta is within the multiplication of 1. So it can be rewritten as tan pi by 4 into tan theta. So d by dx and your tan inverse still remain as it is. This bracket is in form of tan alpha plus tan beta upon 1 minus tan alpha tan beta, where your alpha is pi by 4 and beta is theta, which is equal to tan alpha plus beta. So we can rewrite as tan alpha, which is your pi by 4, plus beta, which is your theta. Your theta is belongs to 0 to pi by 2. So we can say we just have to differentiate pi by 4 plus theta, or we can say we have to differentiate pi by 4 plus, instead of theta we have to put half cos inverse of x square. So differentiation of pi by 4 will be 0 because it's a purely constant term. Now to differentiate second term, we don't have to worry about this half. We just have to differentiate cos inverse x square, and for that we have to consider box around the x square because it's an inner function. Now differentiation of cos inverse box is minus 1 upon under root of 1 minus box square into d by dx of your box. Within the box we have x square, so we just have to multiply differentiation of x square, which is 2x. We can cancel out this 2 and we will get minus x upon under root of 1 minus x raised to 4 as your final answer. Ta-da!